Okay, this lesson is on the applications of rational expressions or equations. We're going to start with solving some formulas. Solving formulas. Our first example will be 1 over a equals 1 over b plus 1 over c. And we're going to solve for b. Now, just like when you solve a rational equation, what you need to do as your first step is multiply both sides by the LCD, the common denominator. That eliminates all the fractions. I'm going to do exactly the same thing here. I'm going to, since the LCD for this equation is ABC, I'm going to multiply both sides by ABC. That side and that side. Okay, we always do that as our first step. Simplifying now, on the left here, the a's will cancel, and I'm left with b times c. And on the right side, ABC times 1 over b, the b's cancel away, you're left with AC. And then distributing ABC times 1 over c, the c's cancel away, and that leaves you with AB. Okay, so if we multiply both sides by the common denominator, we've eliminated all the fractions. Now remember that we're solving for b here. We're trying to solve for b. So it would be incorrect to do this. You don't want to just divide both sides by c and cancel the c's out. And that's because we still have b on this side as well. You can't have b's on both sides. So let me back up. Since I have a b over here and a b here, I want those terms on the same side. So I'm going to take this term ab and move it to the other side where it will become negative. Negative ab equals ac. Okay, so now I've got all the b's on one side. All the terms without b are on the other side. Now, what this will allow me to do is factor b out of the left side. b is factored out and leaves me with c minus a, like that. Now I'm down to my last step to solve this for b. Now all I've got to do is divide both sides by c minus a, like that. These will cancel, and I will be left with b equals ac over c minus a. And I have it solved for b. Now, depending on which side you move the terms, you could have ended up with an answer that looked a little different. If you factor a negative 1 out of the denominator, remember if you factor a negative 1 out of c minus a, it just reverses the order there. And the negative sign there is right in front here. This is also an acceptable answer. Okay, depending on how you solve the equation, you could get either one, and both are acceptable. Let's try another one similar to this. Solve for x. And we have the equation y equals x plus z over a minus x. Okay. Remember, the first step is to get rid of all the fractions by multiplying both sides by the common denominator. Well, there's only one denominator here. It's a minus x. So I'm going to multiply both sides by a minus x. Just like that. Doing that, they will cancel on this side. I have x plus z. On the left side, I've got to distribute. This is a times y minus xy. I've eliminated all the fractions. Now remember that we're trying to solve for x. So what I need is all the terms with x on one side. All the x's on one side. So what I'm going to do is I'm going to, let's see here, I'm going to move this negative xy to the other side, so it's like adding xy to both sides. I now have ay equals x plus xy plus z. Now any term that does not have x in it, I want on the other side, and so I'm going to get rid of the z here, subtract z and move it to the other side. And that now gives me ay minus z equals x plus xy. Okay, so I've got all the terms with x's on the right side, and I've got all the terms without x's on the left side. The next step is to factor x out. If I factor x out of the right side, I'm left with 1 plus y, like that. This side is the same. Now I'm down to my last step. To solve for x, I'm now going to divide both sides by 1 plus y, just like that. The 1 plus y's cancel, and I'm left with x equals ay minus z over 1 plus y. And we have it solved. Solved for x. Okay, let's try another. Back up. Solve for z. We've got 1 over x plus 1 over z equals 1 over y. So this one's very similar to the first one we did. The LCD is xyz. So I'm going to multiply both sides by that. This side multiplied by xyz, and this side by xyz. Distributing. The x's cancel there, leaves me with yz. This times this, the z's cancel away and leave me with xy. And on the right side here, the y's are gone, and that leaves me with xz. Okay, now remember we're trying to solve for z here. So I need all the terms with z on one side and all the terms without z on the other side. So the easiest way to do that is to subtract yz from both sides, just like that. So we've got xy equals xz minus yz. I can now factor z out, because that's what I'm trying to solve for. xy equals z times x minus y. And now finally dividing both sides by x minus y, I end up with z, right here, equals xy over x minus y. And we have it solved. And remember that if you moved everything to the other side, we could have got a slightly different answer. If I factor a negative 1 out of x minus y, that leaves me with y minus x, and there's a negative sign in the front. This is also an acceptable answer that you could have gotten. All right. Solve for capital T. PV over T equals little t, little v over little t. Okay. So we got capital letters and lowercase letters in this one. So we want to solve for capital T. So I have to first multiply both sides by the LCD, which is the little t times the big T. Common denominator. So multiplying both sides by that, little t times big T, little t times big T. On the left side, the t's cancel away, the capital T's that is, and that leaves me with little t, capital V. On the right side, the little t's will cancel, and that will leave me with little p, little v, and capital T. Okay, now we're trying to solve for capital T. So there's only one capital T in the equation. It's right here. So all I need to do to solve for capital T is just divide the little t and the little v away on both sides like that. Just cancel. And my answer will be capital T equals little t, capital P, capital V, over little t, little v. And it is solved for capital T. A couple more. Solve for V1. The equation is A equals V1 minus V2 over little t. First thing I do is multiply both sides by the common denominator, and that's just little t here. So, multiply both sides by little t. This will eliminate the fractions. On the left side, we have a times t. On the right side, the t's canceled away and leaves me at v1 minus v2. Now, since I'm trying to solve for v1, all I've got to do is add the v2 to the other side, like that. And I have v1 equals at plus v2. Or if I turn that around, v1 equals at plus v2 this way. And we have it solved for v1. One more example of solving formulas here. Solve for n. We've got capital S equals n over 2 times a plus L times d. Okay, remember the first thing we want to do is eliminate the fractions. And the only denominator in there is a 2. So I'm going to have to multiply both sides by 2 first. So times 2 and times 2. On the left side, we have 2s. On the right side, the 2's cancel away, and that leaves me with n times a plus L times d. 2s over here. Now, I'm not quite sure why I have the d on the end here, but d and the n have to be multiplied in. That's the same as n times d times a plus L. So I'm going to distribute it in. Excuse me. Or actually, wait a second. We do not need to distribute it in. This is just multiplication. N times d times a plus L. So all I've got to do actually is one last step. Divide both sides by d a plus L. d a plus L. This will all cancel away. And we are left with n on the right side when I moved it to the left. And that will equal 2s over d, f plus b d there, d a plus L. And we have the formula solved now for n. Okay, that's how we solve formulas. Some other applications of the rational equation is a proportion. In 2002, 15 of every 100 Americans had no health insurance. The population at that time was about 288 million. How many million Americans had no health insurance? Okay, so we need to define a variable. Let x equal number of millions without health insurance. Now I'm going to set up a proportion. That's like a fraction equaling a fraction. 15 out of 100 Americans had no health insurance. That should be the same as x over the entire population, 288. Okay, I've set up my proportion. Now, proportions can be solved with a shortcut. I can cross-multiply. And that means I can multiply these together, which would give me 100x, and that will equal this times this, 15 times 288, which, using my calculator here, is 4320. Oops, wrong color. Divide by 100, and we got 43.2. And that's in millions, so the answer is 43.2 million Americans. Here's another example of setting up a proportion. Marissa's car uses 10 gallons of gas to travel 210 miles. She has 5 gallons of gas in the car and still needs to drive 640 miles. How many more gallons will she need? So we're going to let x equal the number of gallons needed. Now 10 gallons of gas gives her 210 miles, so that's going to be one of the fractions. 10 gallons is over 210 miles. You could leave the gallons and the miles out, but sometimes it helps. That should be the same as some gallons over miles again. So how many gallons do we have now? She has 5 gallons in the tank still, and we want to know how many more gallons, so plus x. So we're adding in how many more gallons to those 5 gallons that she has, and we need that to get us 640 miles. So we got to put a 640 there. Okay, so up here we have gallons, and this is miles. So you got to make sure that if you have gallons over miles here, it should match there, gallons over miles. You can't have them reversed. You can't have one side reversed from the other. Okay, I'm going to solve this by cross-multiplying. So I've got 210 times 5 plus x, and that should equal 10 times 640, which is 6,400. 6,400, there we go. Okay, distribute the 210. Or actually, I can divide by 210. Divide by both sides by 210. 5 plus x equals it's about 30.5 approximately. And then subtract 5 from both sides. And we have about 25.5. And so our answer is 25.5 more gallons are needed to get us the 640 miles. Okay, those are 2 examples of setting up a proportion to solve a word problem.